Hello, my friends, and welcome back. I'm seeing you after such a long time. Today, we will be making a speed display for toy vehicles such as Hot Wheels. Let's see it in action. This is the setup that we'll be using. As you can see, I am launching the vehicle, and now the display is displaying the speed of the vehicle. This project uses two IR sensors which can detect when the car passes in front of them, an ATmega 328 which processes these measurements, and an LCD display to display the speed of the vehicle. These IR sensors often have different pinouts. For example, this one has the output pin in the middle, but this one has the power pin in the middle. Now let's go on to the actual circuit diagram. Now let's take a look at the circuit for this project. This project is powered by a 9-volt battery and a voltage regulator, which I used an LM7805 here, converts the 9-volt signal to 5 volts. This is connected to the power pins of the ATmega 328 processor. This is the same processor which is used in all Arduino Uno boards. Two of its pins are connected to the 16 MHz crystal and also to these two 10 picofarad capacitors. The other pins of the capacitors are connected to ground. To sense the motion of the car, this project uses two IR sensors placed at a distance of 20 centimeters from each other. These two are powered by the same voltage regulator, and their signals go to pin 2 and pin 3 of the Atmega 328 controller. This is a 16 into 2 LCD character display, and it is meant to display text and some images. We use it to show how much speed the car is traveling at. It is powered by the same voltage regulator, and pins 4, 5, 6, 7, 8 and 9 of the Atmega 328 are connected to it. Its backlight is connected to the same voltage regulator, and its contrast pin is permanently tied to ground. We could also connect this to a potentiometer if adjustable contrast is required. This schematic will also be shared in the description. Let's move on to the code. Now let's take a look at the code. The first thing we do in the speed display code is we include the liquid crystal library. This is a built-in library which comes with Arduino IDE to display text and bitmap images on LCD displays. Then we initialize a few variables. This variable indicates the pin number to which the starting sensor is connected. This one indicates the pin to which the ending sensor is connected. This variable is the distance in centimeters between the two sensors. And these are the pins for the LCD display. After this, we have a variable to indicate the speed of the vehicle. And then we have a few volatile variables. In the Arduino IDE, volatile means that it can be accessed within interrupt service routines. The purpose of these two variables will be explained later. And this is the starting time and the ending time at which the start and end timers were triggered in milliseconds. Here we initialize an LCD object. Then we attach falling interrupts to the starting sensor pin and the ending sensor pin. What falling means is that if the pin has a transition from high to low, it will be triggered. This is because my sensors output a low signal when an object is in front of them. If you have another type of sensor which outputs a high signal when a sensor is in front of it, then you might want to add the word rising instead of falling. Then we initialize the LCD object at 16 and 2. This means 16 columns and 2 rows, which is the size of the LCD that I am using. In the loop function, if the measurements are ready, which they're set to in the starting. It calculates the speed. How does it calculate the speed? The first thing it does is it calculates the time which the car took to travel from sensor A to sensor B. How does it do this? First thing, it subtracts the starting time from the ending time to get the elapsed time in milliseconds. Then it divides this by 1000 to get the elapsed time in seconds. This is the time which the car took to travel from the starting sensor to the ending sensor. Then it divides this value and this one, which is the distance. You might recall that speed equals to distance divided by time. This is exactly what we're doing here. Then we set the cursor to the top left corner, print the speed, set the cursor to the bottom left corner, and print the unit centimeters per second. Now we have the functions which are triggered by the interrupts. In the start timer function, which is triggered by the starting sensor, we read the milliseconds to the start time variable. This function outputs the number of milliseconds which have passed since the controller was booted up. Then it sets this ready variable to low so that it does not display these values until the ending timer is triggered. And it sets this variable to high. Now we'll see why this is set to high. In the end timer function, if this value is high, because Arduino is case sensitive, it reads the ending time in milliseconds, sets this if condition to true, and makes this low. You might be wondering why we have this variable. When I was testing this circuit, I found that if you triggered the starting sensor and then triggered the ending sensor a number of times, the speed would keep getting lower each time you triggered the ending sensor. Why? Because the elapsed time would keep getting greater. Now it can only trigger once, and then this will be set to low so that this cannot trigger again until it's set to high here. This calculation easily finds the speed by doing distance divided by elapsed time. This code will also be provided in the description. Thank you, and I hope you enjoyed my video. I'll be providing the schematic and the code in the description. And keep watching and definitely subscribe. Bye.